Well, man. It's a great day to have a beard. If you don't have one yet, I suggest you get one. Hey, we're going to be talking about Exponents Part 2 today. And, let's get into it. Now, oh man, before we do, as always, remember, uh, learning is not a passive activity. It requires active engagement. You have to be a willing participant to take on confusing things, figure them out. It takes a little bit of work. It can be uncomfortable. Once you get used to it, it's kind of like lifting weights. You start to appreciate that feeling of being uncomfortable because you understand the growth that comes as a result. So, pause the video, take notes, try practice problems, all that kind of stuff. Let's get to it, shall we? Um, Here's what we got going on, boys and girls. We're going to be dealing with arithmetic today. Exponents Part 2. It's arithmetic. Add, subtract, multiply, and divide. We're actually going to get into the division um, later, but yeah, for now, add, subtract, multiply, divide, shall we? So these are the two things. These are the two kind of shortcuts we learned last time, and they both come from the fact that exponents are a way of writing um, multiplication that's repeated. Just like, remember, uh, 5 times 3 is the same as 5 plus 5 plus 5. And 5 to the power of 3 is 5 times 5 times 5. That's what it means. That's what it means. So when you just have, 5 times 3, 5 to the power of 3, they're just they're written in math. Math is a written language, and so these are what they mean right here. Do you see? All right. So what ends up happening is you're going to end up with stuff like this. Let's say we had 2x squared times 5x to the third. Well, check this out. This is all multiplication, and multiplication has a commutative property. So you can rearrange it. Now, I would never rewrite it like this, but this is what you should recognize when you look at it. That is 10x to the fifth. Do you see? Whereas if you had something like this, a squared b cubed times, let's say a to the third b to the fifth. Ooh, look at that. This is, see how the a's are the same and the b's are the same? That's like an application of this right here. So this would be a to the fifth, b to the eighth. So the idea is you're looking for the bases that are the same, and you're combining those by using this process right here. So if that's a new idea to you, you should pause the video, write it down. I'll say it again, because this is kind of I know this is a sticking point. Like when we have just one thing, if these were just A's and not A's and B's, then nobody has too much trouble. But when there's A's and B's combined, then people get a little overwhelmed. But here's the thing. We're looking for bases that are the same that are being multiplied, because then we can add those exponents. So what we're doing is we're putting those A's together and we're putting those B's together. We're kind of looking at it as if it's two separate things, but it's really one. It's all put together. All right. Now, what if you had something like this? What if you had something like 3 squared a squared b times, let's say a to the third b c to the seventh. Ooh, try that one. Go ahead and pause it. Try it. See what you got. We're just using this rule right here. Okay, did you get this? You could write 9, but let's leave it 3 squared. Or 9. Same way. It doesn't matter. Either way is fine. Like, if you can do the arithmetic in your head super easy, then it makes sense to write it out. You could write it as an exponent as well, but one of the benefits of exponents is that you don't have to do the arithmetic. That's the whole purpose. So anyway, 3 squared, and then look, we have 2 a's here multiplying with 3 a's there. Well, that's 5 a's, right? 1 b, another b, that's 2 of them. They're multiplying. And there's c to the 7th, and that's it. Dang, dang, dang. Okay, moving on. Okay, the trickiest one. Ready? Oh, man. Hope you're buckled up. What if we did this? What if you did a squared times a to the power of b? Oh, man, how would you do that? Huh. Well, would you agree that the bases are the same here? They're both a, and that we're dealing with multiplication. We're not dealing with addition. If it was a squared plus a, if it was a squared plus a to the power of b, well, then we have a different situation in our hands. But this is multiplication. Exponents are repeated multiplication. So what we can do is we can add those. So, like, for example, let's say that b was actually 3. Well, this is what you'd get, right? You would actually never write this intermediary step there. You would never write that. You would just do that in your head. Well, here we can't actually carry out this addition because we don't know what b is. So we just leave it just like that. Do you see? All right. Oh man, that's going pretty good, right? How you guys doing? Feeling good? Oh man, let me know. I guess you'd have to leave me a comment, but that's some good H2O right there. Okay. Oh man. So yeah, there we go. That's it right there. That's all there is to it. Super easy. What if you had something like this? Ooh, man. So this is the first part. What if you had something like this? What if you had 3x squared plus 5x squared? Well, that would be 8x squared. Oh man, when you're doing addition, the exponents don't change. The reason why, exponents are repeated multiplication. This is addition, so they don't change. Whereas if you had something like this, well, that would be 15x to the fourth. Do you see? Yeah, so if you're adding, the exponents don't change. But if you're multiplying, the exponents do change. Okay, what if, let's move on now. Let's say we're gonna, let's do this one right here where we did a to the b to the power of c, and that's a to the b times c. Now the reason that was, again, in case you forgot, if you had x squared to the third, well, that'd be x squared, x squared, x squared, because for this exponent of 3, the base is x squared. So that means we have 3 of the base multiplying. So 1, 2, 3 of the base all multiplying. And we know that this would be 2x's multiplying, 2x's multiplying, 2x's multiplying. So that would be 6 of them. Yeah? Okay. So oh, try that. Go ahead and pause the video. See if you got this. Now, what everybody always does that's wrong is they do this. That's wrong, okay? That's no-go. It's not 3 times 4. The thing that's tricky here is that this has an exponent of 1. So this is actually 3 to the 4th, x to the ocho. You see, that's how that works. Yep. Oh, man. What if, okay, here comes a tricky one. What if you had, let's say, 5 times 3x squared to the 4th? Ooh, that one's trickier. You see, here, it's true, this 5 does have an exponent, but the exponent is 1, and it's not in the group, so it's not going to be multiplied. It's not in this group with that power of 4, so this is multiplied by itself 4 times. This is just once. So if you wrote this all out, this would be 5 times 3x squared, 4 times. That's what this would be. Do you see? There's just one 5. There are 4 3's. That's why it ends up being 5 times 3 to the 4th, x to the 8th. How are we doing? Kind of trying to unpack all of this for you so that when you see some big ugly question, you can pull it all together. That's the plan. That's the hope right here. What if you had something like this? What if you had 5, 3 squared x to the 3rd to the 4th? Could you handle that? Why don't you give it a shot? Go ahead, try it. Pause the video. Okay, here we go. 5 times 3 to the 8th x to the 12th. That's what it would be. Now, if you wanted to figure out what this number would be, you'd of course have to multiply 3 times itself 8 times, then multiply that product by 5, like that. Okay, onward and upward to greater things. Now, check this out. Here are here. Let's see if we can put all of this together right here. Ready? So let's say we did 2 times x squared y to the 3rd. Let's say plus 3 x y to, let's see. Oh, let's see if we can handle that. You ready? So check this out. This one's a little confusing. We've got lots of 2's and 3's there. So first of all, if we can add these, that means these two things have to be the same. If they're different, you can't add them. So this one right here would be 2x to the 6th y cubed. This would be 3x to the 6th y squared. You see, those y's aren't the same, so these are not what you call like terms. So you can't add them together. So you're done right there. There's nothing else that you could do. They are DONE, finished. Done. Yeah, yeah. Okay. What if you had something like this? What if you had, let's say we had something like 5, and let's say we had x squared y to the third to the fourth. Yeah, you follow me? Good so far? Um, and let's say we're going to add that to, say, 2 x, let's say x to the fourth. Let's see. Ooh, what if we had that? Man, check that out. That looks pretty overwhelming, right? Well, let's go back to our basics, okay? Here's what we know. We know, first of all, that you have a base to the power of an exponent, and what that really means is whatever the number is here, it's multiplied by itself that many times. That's the most basic, right? If there's not anything written there, then there's really a 1. There's an invisible 1. We also know that if the bases are the same, that you can add those exponents. We also know that if you raise a power to a power, that's how we say it, that you can multiply those. That's the shortcuts, right? And all of these come from this idea that exponents are just a shorthand way of writing repeated multiplication. So here, this 5 and this 2, they're both neither of them. Neither of them are in the parentheses, so we can't, we're not going to multiply this by them right there, right? So here's what we got. This one's going to be 5, and then x to the 8th, y to the 12th, because the base for this 4 is x squared y to the third. Do you see? X. Now, if the 5 was in here, the 5 really does have an invisible exponent of 1. So if the 5 was inside the parentheses, it would be 5 to the fourth. But it's outside, so it's not. Same here with this 2. It has an invisible exponent of 1, but it's not inside the group. This group is a base for this exponent of 2 right there. So this is plus 2 x to the 8th, y to the 12th. Now check this out. That's addition. Do you see? So this is 7x to the 8th, y to the 12th. These are the things that are being multiplied by this 5 and that 2. This means that there are 5 of these adding, and this says it's adding to 2 of those things adding. So like if you did 5a plus 2a, this right here means a plus a plus a plus a, that's 4, plus a, and then plus, right? And then 2 a's. That's 7 a's. Do you see? Same thing here. There are 5 of these adding plus 2 of the same thing adding. That makes 7 of them all adding. Man, a lot of stuff there, right? Well, I hope you guys have done well. If you're feeling a little overwhelmed, it might be a good idea to try the homework, try the practice problems, watch the video again. Give it some time maybe. Take a little break. Half an hour. Watch it maybe later tonight. Rewatch it, take notes again, read your notes from before, watch it, retake notes. Those are the things that you can do, the small little things that you can do that will alleviate a lot of that pressure you're feeling. If you're just like, oh, I got to figure it out, and you think you're going to figure it out by just focusing on the homework, you're going to just end up getting in this cycle where you're perpetually stuck, and that's no fun, right? So anyway, hope this has been helpful, and I hope you guys have a wonderful day. I'll talk to you soon.